So welcome, as Fleming said, my name is Andreas Dyrhed. I'm the CEO of Nohau. And I would also like to thank my colleagues in Denmark for hosting this. So this is actually kind of a, sorry. My presentation froze. No. So this is actually a roadshow we've had. So we started in Helsinki 2 days ago, and then in Gothenburg yesterday, and now we're finishing off here in Copenhagen. So hopefully we're also kind of warmed up now, and there's something with this screen. This happened before. Some glitch. No, and we think this is a good way to gather people we work with and people we possibly could work with, and also our partners. And you may well know Nohau already, but if you don't, so we are a company focusing on basically doing software development better. We make sure that our clients do that, and that means doing it faster, doing it with higher quality, more security, and we do it through products and tools, and training and courses, and also services, some services also, to facilitate this. And the reason we actually have this FuSA, or Functional Safety Seminar, is that we've seen before, we've been in this for a long time, and that the products we work with and the training we have cover so many aspects of functional safety, the whole cycle of it. If we look at the old classic V model for it, but actually that's the way you should do it. And then we see we cover a lot of this, and that's why we do this. Because we work with tools that help the developers, debuggers, compilers. You have the QA tools for unit testing, code analysis, and also, of course, you have requirements management, and all the other things surrounding this. And then you have the whole certification problem, which we're also going to hear more about today. So the speakers we're going to hear from today is, first out is Rizwan from Huld. And then, I'm not sure about the order, but probably Vladimir from ARM will talk. And then my colleague Joachim will talk about code analysis, or Matt Davies from QA Systems. That's the order, sorry. Yeah. And then Thomas Meyer from TÜV Süd will talk about actually certification for functional safety. And then also from Lauterbach, Ladislav and Christoph will join us. They are replacing Daniel, who got ill, so they will be joined online. But otherwise, we really think that, and we've seen at the other cities we've been at, that this has been a good day with interesting presentations, and hopefully you'll find things in each presentation that are of interest when it comes to functional safety. So once again, welcome, and I'm handing over to Rizwan.
So the topic I want to discuss today is what we call cybersafety. It's kind of a coupling between two different systems, cybersecurity and functional safety. Why this is important, why is the industry changing, and why would this be more important than ever in the future, in the near future actually. But before that, a few words about our company and what we do. Huld is a Finnish company. We have around 14 offices around Finland and then one in the Czech Republic. It's a merger of several years from within several small companies together. So we do different sort of services, as you can see, you can see from the what we offer side of things, from hardware design to software, product development and design, digital design. But what's important in this slide is that we have a merged team of safety and security. I'll talk about that in a bit, that why is that important and how we see that this is going to be the future of every other industry as well. Apart from that, you can see that we come from a vast, let's say, knowledge field and a lot of experts that come from different industries, and then we work together. My background comes from the space industry. I used to work for this company called Space Systems Finland, which became part of Huld. And now we are all working together, which empowered us to see things a little differently and a little more broad way, if you might say. My own background, I'm currently handling a couple of accounts at Huld, and I'm working on developing the business for functional safety. My background is in autonomous systems, so robotics, AI, and that sort of sweet stuff. And I've been working with functional safety for a couple of years now, and most of my projects relate to either robotics or machinery. Some medical devices, but I would not like to do that again. My colleague Anton gave the same presentation in Helsinki, but I will skip that. And so this coupling that I mentioned between safety and security. So when we think about cybersecurity, we usually think about, hey, data, making sure the data is safe, making sure the data is going to the right places, and it can be accessible by everyone. When we think about functional safety, we usually think about, hey, whatever machine we're making, it does not hurt anyone or does not hurt the environment or does not hurt any assets in that way. But if we took a step back and see how the industry is evolving, we saw the industrial revolutions picking up pace and then reaching to a level where we are now. Now we're in the digitization phase, that everything is going digital. IoT is picking up pace. You have more investments in the IT sector. Every company has an IT sector. We all use perhaps Teams or some sort of equivalent application. Similar goes with the industries or, let's say, normal factories in a way, that the production line is getting digitized. But what's next? How are things going to pick up? And the next step would be personalization. That, hey, we do need XYZ machines, but we need them personalized to our system itself. We use XYZ softwares and we use this kind of stack, and then we, of course, need your machine to be personalized in a way. But if we look way back, machines used to be simple. It used to be this yellow box with some safety stickers on top of it. Hey, don't crush your hand or anything. You send it to the customer, and that's it. But now things are changing. Now, when it comes to products, whenever you sell something either to a factory or to the commercial sector, there is post-sale services that needs to be taken into account. Simple example, if you sell, let's say, a mobile phone, you need to ensure 5 years of software updates. If you sell, let's say, a thermostat, that needs some updates every year. If you sell a heavy robot, that needs some maintenance, that needs some software update, that needs some new safety features that's coming in. One example that I really like that comes from this Nest IoT hubs, these Nest thermostats, or well, the company that produces thermostats, they also produce these fire alarms for home. And there was a system in that, in those fire alarms that in the kitchen, if you accidentally burn something, it's not threatening, but the alarm goes off, it's annoying. So they built a system with an image recognition that, hey, if you stand below the fire alarm and wave at it, it'll go off. The false alarm will go off, and that was okay, understandable. But then the company found out that in a lab test, they made an artificial fire or a controlled fire and were testing it. It happened to be that the image recognition thought that the fire was waving at it. So that happened, and well, panic mode, panic button start. What now? The thermostats are out, people are using them at home. What to do now? That's when they pushed basically one button and they disabled that feature. So that's the post-sale service that I'm talking about, and it's all digitized. And of course, to make that system safer, that disable button, that disable service need to be secured. So that's the post-sale service that we can see from the example. When we look at cyber physical system, Springer definitions, I'm not going to read this through, but you can see the requirements which are still applicable. Industry is changing, but we can all agree that these requirements are applicable. When it comes to functional safety, you can say the first four, but now let's talk about how security comes into this. One thing to notice here is what we call the legacy operational technology. These are the yellow boxes that we used to sell, and then it will be installed in a factory. It will just stay there. We're going to discuss how industry change is affecting those devices. What are people demanding regarding those devices in a little bit, but let's see an example of our normal functional safety process. So we have process control automation. What's the nominal steps that we do? We define a SIL level, we do a HADA, we write the RAM's requirements, do the implementation, and then there's the verification step. Pretty simple, pretty what we see in 61508. That's how it goes. But what if there is some input coming that's remote? Now you have an IoT system within it. You install the crane, but in the future they made it remote, they made it wireless or something like that. And then it's being controlled remotely from somewhere. And let's say a safety system was turned off, the safety system of the waving thing, someone accidentally turned it off. Now the consumers don't know that our feature is off. It's annoying, fine, but in a more extreme case, what if the robot safety system was off? You open the cage, you go into the robot, in the robot's, let's say, room where it's working right now, assuming it'll turn off by seeing a human. It doesn't, it harms the human. This wasn't taken into account when we were doing the SIL processes, when we were not thinking about this, when we were thinking that, hey, here's a robot, it's in a cage, the cage door opens, it turns off. But then there was a remote feature that was added into that. And like I said, with the industry changing, that feature would be required. So yeah, a couple of hazards that we initially didn't take into account are listed here. And of course, the idea is, or the kind of message that I'm trying to give here is that in the initial processes, cybersecurity should have been taken into account. But what are the challenges here? So I mentioned about the OT technologies, these operational or legacy technologies. The thing is, we have factories available, we have these yellow boxes available, and easiest is you move to, let's say, this IoT-based CoAP or MQTT-based protocols and devices that enable them. But then the question becomes, how much money do you have? Can you replace every machine with that? Sometimes yes, sometimes no. But when it comes to these OT technologies, there are challenges. Imagine putting a firewall on a very, very old device. Continuing on, well, we could, for example, make them safe. We could add some system on top of it. But then what happens? Well, here are some examples. So these are some well-known cybersecurity, let's say, attempts to disable national level infrastructure. So these were state level attacks. One example that we can take today is, for example, Stuxnet. And the story is that Iranian prime minister was with some media and he was showing around that how our nuclear facilities are safe. And while that was being filmed, the PLCs turned off remotely. And the story is that some documents got leaked and then they went back and then they figured out and then they custom tailored a solution or a malware that will go off when the media was present. We saw similar attacks in the Ukrainian power grid, and all it took was an Excel attachment to do this. So these are state-level attacks that happened and could cause huge damage to the infrastructure. Well, these were, for example, Iran and Ukraine, but there were similar attacks in the US as well when it comes to these chemical industries. And you can imagine, so one thing you can notice is that, okay, from the nuclear side, fine, you need to upgrade it, there should be some more. But then the smaller level, for example, simpler chemical plants or something like that, or maybe a fertilizer plant, again, the thing is, if a certain safety system goes off remotely, that could cause heavy damages. So what have we discussed so far? One is this operation technology and IoT, not necessarily the best solution that you suggest your customers, hey, just replace all your factory with a more modern system. Not possible every time. Then industrial systems are upgrading. We are seeing more connectivity. There will be more in the future. Like I said, right now we're in the digitization phase where these OT technologies are either being hardened or they're replaced by IoT technologies. Next step will be personalization. Then OT security, sometimes it also happens the other way around, that you have a newer system, you bought a very good, let's say, machinery in a way, installed it in your factory, but your IT system is lagging behind, and you have to take that into account. There's a standardization legalization aspect to this, but we'll discuss it a bit later down the line. So, like I mentioned in the start, our team, we recently merged our security and safety teams together. So that gives us a chance to work in close collaboration, talk with the people, let's say for my background was in functional safety, but then talking with the people from cybersecurity, we found out there are some synergies. There are some ways that, okay, I took some, for example, cybersecurity projects as well to see how it works, and there were some synergies that we found. There were some challenges as well, so let's dive into them one by one. So just to reiterate the point, safety, security, both are important, and both will cause problems to the same, let's say, well, the result of ignoring any of them will cause, for example, loss of availability, injuries, or asset damage or environmental damages. So if both sides are contributing, if both systems are contributing to the same problem, that means there should be a common solution available, or at least both need to be taken account together. So what we did was we looked into the regulations to see that, okay, security and safety, what are the commonalities, what are the differences, how can we work together, and how can we take into account both of them. I'll talk a bit more of the regulations a bit later, but continuing on, there are some cybersecurity threats to OT technologies that we have to take into account, and there are some threats related to new technologies with a bad IT system that we need to take into account. Complexity of requirements is increasing. So one requirement that I mentioned recently was this requirement for updatable software. It's not only the software or this remote system that you need to panic button that you need to press to disable a system, but it's also the internet protocols. One example, simplest example, cryptography. You encrypted all your data that goes from one device to the other or from your center to all your devices. Well, now we have quantum computing that's coming in. And these cryptography methodologies will get, for example, redundant at some point. That means they need to be updated. So whenever you're pushing out a device or creating a new device, you have to take into account that the protocols might change. So the complexity is increasing. And then, yeah, I've already discussed about some overlaps of synergies, but I will talk about them now, that how or what do I mean by them. So there are some quality synergies, that there is a higher level of competence in completeness of that work. Disclaimer here, we have worked with, for example, cyber safety, security and safety together with some projects, but we haven't reached certification yet. At least in our experience, we haven't really done a certification which check marks that, okay, this is cyber safe. But we have, for example, created work that we can have higher confidence in completeness. That's something I can say that from our perspective, we feel that it's complete. Why we haven't achieved certification yet? Well, there is no harmonized standard currently. And that's the reason that even if we go to, for example, FuSA, and then we ask that, hey, we need a certification, there's nothing they can check it against. So we'll talk a bit more about what I mean by this and what kind of issues did we face. But let's look at the commonalities. That, hey, what would be an advanced cyber safety protection in this case? So you have your normal process control automation. You have two sides. You have the safety and then the security. So in safety, as we know, we define system integrity levels, or safety integrity levels, sorry. In security, we define, for example, security levels, 1, 2, 3, 4. Then, of course, we identify the hazards. On the other side, we identify threats. Then we have our requirements in a way. We have security requirements. Here we have RAMS requirements. The implementation, fine, it's a bit different. And then there is, of course, a verification, which varies a lot from both sides. So you do these processes in parallel. You find out both the SLs, the SILs, and try to create a process that is, again, cyber safe. Cyber safe in the sense that you have cyber defense, and then you have a safe industrial process. It won't harm a human, and the system would be secure on its own. Right, so easy enough, right? You have both sides, do it parallel, you should be good. Well, it's easier said than done. And that's what I want to discuss next. So some commonalities that we have, for example, with the standards itself. So we have, for example, 62443, which is an ICAS standard, mostly relates to security. But we've seen that that can be molded, or it could introduce some aspects of safety as well. It's not just a cybersecurity standard in that way. You have architectures. Of course, when you create architectures, you have to take into account there's the software part with the embedded systems part. There is, for example, common coding standards that you can use. There are some overlaps between that you can, when you're selecting a coding standards, take into account that, hey, let's find a standard that's safe and secure. Threat modeling, hazard analysis. I'll talk about that in a bit, that there are some hysterics in there, but on a higher level, you can say that this can be used together. Right, so if we go into more details of what 61508 says in terms of safety, and then the security part, you can see that the main process itself, the development lifecycle, is pretty much, let's say, aligned in a way. And you can do both sides within, let's say, a common lifecycle or a common process. Lots of information, as you can see here. From in between, you can see the MISTRA certifications or WASP and these kind of analysis. And on the other side, when it comes to software requirements, you can go, for example, software safety requirement, unit test plans, and everything. And as you can see, something can be overlapped in between. So if I simplify this diagram, you go, as usual, with the requirements, you start with the common HARA and TARA. Look into those. Do some common requirements, and then planning in a way where whatever your safety plan or concept is. You need to have a common safety and security architecture. That is important. Then common coding standards, and then, of course, at the end, the integration and testing part. You need to have both sides. When it's an independent safety assessor, it should be an independent, let's say, cybersecurity assessor as well. And that can be done together, of course. Hysterics, not really that simple, but of course, we can look into those a bit later. So, talking about this new TS 63074, this was an attempt to bring, well, before I discuss this standard called 62443, that comes from the security side. It's a cybersecurity standard that has some aspects of the functional safety side. Well, this TS 63074 comes from the functional safety side and tries to integrate some of the security aspects in it. However, majority of these threats are not even safety related. They do address a lot of like cybersecurity, let's say, threats, but when it comes to safety related ones, they kind of bug out of those. Then the biggest kind of gap we saw in these standards was the common risk matrix. There's an attempt to do this, but it doesn't address, let's say, it doesn't address the whole lot of challenges that we have or all threats that we can have. Some of them, for example, what about availability or loss of production? What about the reputation damage, the data leaks and everything? These are issues that cannot be translated into a SIL. And similarly, some of the security issues that cannot be translated into an SL. So the common risk matrix needs to be updated in the future to be able for us to have a more harmonized standard. Then this 63074 discusses security assessment risk triggers and challenges. Well, there are some triggers that it mentions that, hey, what would be, let's say, a no-go situation for us. It mentions these triggers, and when we talk about current industries, these OT technologies, most of them are not implemented. And when they're not implemented, that means that we can't do an assessment any further. One thing we know, for example, from a COTS or open source software updates, like I mentioned, remote updates and applying those, well, these are not here. It does not address, for example, there's one machine and producing different products, or using one machine for XYZ product for 1 year and then ABC for another couple of years. It doesn't address those issues. So what kind of problems do we have when this happens? When you have, for example, cybersecurity, and then you have cybersecurity, and then you have functional safety. For example, we do a functional safety study on some machine, and we provide a set of standards to you, or a set of requirements to you. And then you did, from an independent party, a cybersecurity assessment on the same product, and then they give you a set of requirements. And what if they're clashing? The product manager will panic that, hey, what do I do at the end? So the reason why I'm emphasizing this a lot, or basically our team believes that this is going to be something that we need to address together in the future, is inevitable. If you have products and you're doing different, let's say, assessments on it, and then they're clashing, one simple example I can give, let's say you have a mission-critical IoT system that your police force or your medical service officers, you provide them with an IoT watch that, hey, we are going to monitor your vitals. Let's say in a line of duty or somewhere, if something happens, we would like to know immediately so we can send help. You have this mission-critical system available. But then who can look at that data? You have a safety system set up that, hey, there should be an alert. It should set up. We should be able to respond. You take care of all of these things. But what if some regulation says that, hey, who is actually looking at that data? Who is looking at the vitals? Who has information about that data? So you did all safety assessments, all good, very good. And then someone comes in that, hey, you're not doing this legally, GDPR, all that stuff. So we're going to restrict the people who are actually going to look at these vitals. Or let's say, more simply, CCTV footages. Who can look at these CCTV footages? So let's say you have one person looking at some CCTV footage to see that something is happening or something bad happened to someone, XYZ. But now you have restricted them. Not many people can look at it. And what if an incident happens and no one was there to look at it, or no one was there to respond to it? So you can see that from a safety aspect, you're doing everything right. Cybersecurity aspect, new requirements come in. You overthrew the older ones. Now we are in a problem. So if this was to be done together, we could see these problems won't arise. So the legislation, standardization, they're responding in a similar way. That we do have some overlaps. If you can see the central part of what we call ICAS, Industrial Automation and Control Systems. If you hear that word ICAS, then it's usually some of these new standards that are coming out, and they usually address both aspects. I've discussed, for example, the 63074 that comes from the functional safety side and provides some security aspects, and then 62443 that comes from the cybersecurity side and provides some functional safety aspects. So you can see that the standards are adopting to this. They are recognizing that these technologies are coming in. These are going to impact our industries, and the future of industries is going to be digital. But again, just to repeat that there are still some issues that you cannot fully mitigate them. We are working on it. There are some attempts from the regulatory authorities as well to address these, and hopefully we'll see some sort of a harmonized standards by 2026-27. So from Huld, I wanted to give some very over-the-top examples of what we've faced so far. So usually, well, the story is that usually the customers that we get, there are some customers who are well informed and need some help or additional work at the end, but some new companies or companies who are doing functional safety for the first time, they usually come in that, hey, we made this product, we're trying to sell it to a customer or an automotive manufacturer or a car company or something like that. We try to sell it to them, and they ask for, hey, so what's the SIL level on this thing? And we have no idea what that term means. So that's how we help them. So it happens on both sides, that it comes from, they bring us the product and then we have to assess it. happens that they ask, for example, we don't know what SIL means and what can you help us do this cybersecurity or cybersecurity or functional safety assessment. So when we get one customer, and for example, there is this non-safety related customer that came in, and well, we did the safety assessment, but the problem became, well, they came back to us, they were like, hey, so we found out that there are some insecure installations. It's not secured. They were like, yeah, this was the safety stuff we did, not the cyber stuff we did. Similar situations, for example, happened with another customer who wanted to do a safety assessment, but their product was vulnerable to malware. Another example, well, this was from the cybersecurity side, that we did the cybersecurity assessment. We plugged off all the ports and everything that, hey, you cannot do this or that. It should be secured in this way. But then the product was not usable in the factory itself. So these are the issues we've been facing so far. Yes, so that's all I had. Just to, again, recap just a little bit that we do see the industry changing. We've been seeing that for a long time, and change is natural when it comes to our systems on its own. But what we believe in, and that's the reason basically we have a common security and safety team, is to find these synergies between both. And right now our policy, or kind of the way we move forward, is that when we do a safety assessment, we do like to do a cybersecurity assessment on top of it, or harmonize or hand in hand with it. So we've discussed some ways that we've seen and some challenges that we are still facing, and hopefully we can have some solutions soon. So thank you, and I'm happy to answer any questions.